Chapter 5.3. Chapter 5 continues to work with systems of equations, solutions to equations, and what point or points of intersection do they share. In this section 5.3, we're going to use still elimination, but this time we're going to use a different technique. In 5.2, we use substitution. We isolated for one variable and then substituted that equivalent other side of the expression to eliminate one of the variables, so we only had one variable. In this chapter, we are going to do it by adding and subtracting. So let's look at the first example. So we understand that these are sort of balance beams. Right? This side is balanced with this side. There's a fulcrum there, and so these are interchangeable. They are the same. They hold the same values. So if I add this to this balanced equation, and I added this to this side, it would be the same because these are the same. They're interchangeable. They have the same weight. So if I add this to this side and add this to this equal balance, it's still going to be equal. So when we add, first of all, both of these equations are in standard form. We want them to be in the same equation or same structure. Doesn't have to be standard, doesn't have to be slope-intercept. Just that the x and y are on the left side, the x and y should be on the left side of the other equation. And if the constant's on the right, the constant needs to be on the right in the other equation. So we're going to combine like terms. We're going to combine columns as I always explain it. And we will combine the constants from the right side. We like this because what do we notice with the y's? They are opposite of each other. When they're opposite of each other, they will cancel. 2x and 5x make 7x. The y's cancel. And then we're left with 10 plus 11, which is 21. Divide by 7. X equals 3. Look how easy that was. Yes. Now we take either equation. Remember, this is the solution. So we know it's going to work for both equations. We know that is the x value for the solution, so it will work. It doesn't matter which one we plug it in. Plug it in the one that's easiest, or just pick an equation. We're going to plug in that x value to find out what the y value is. Minus 6, y equals 4. And just like that, in a nanosecond, under a minute, we were able to find the solution to the system. Super efficient, especially when they're set up. We are in the same format. The top equation, the right equation, or bottom equation are set up. We're going to combine columns, like terms with like terms. We wouldn't put x's with y's because they wouldn't cancel. You can't combine those. You can't simplify them. So that's the other reason they need to be. These are both x's, so we're left with x's. These are both y's, and they cancel. And then it's equal to my constant, which is -2. I already have the solution. Let's pick an equation. So I'm just going to pick the top one to be consistent. -3x plus 2y equals 14. We're going to plug in -2 for my x. We get 6 plus 2y equals 14. Minus 6, 2y equals 8. Divide by 2, y equals 4. So -2, 4. We could check, oh, it says check your solutions. Let's go back. So I don't have to check it for the top equation because that's how I created the 4. So the only other equation I need to check is the bottom one, 5x minus y equals 11. So 5 times 3 minus 4 equals 11. 15 minus 4, 11 equals 11. So that checked. Let's do the second one. We don't have to do the top equation because that's how I got my 4. So I'm going to check with the other equation. I'm not going to check. I'm going to check with the originals. I want it to be blue. Check in the bottom equation, 4x minus 2y equals negative 16. Let's take those values, negative 2 for x, 4 for y. That's negative 8 minus 8 equals negative 16. And it worked. Good. All right. Okay, wow. So notice that they're not in the same format. I'm going to keep this top equation in standard form. And the bottom equation, I'm going to move the x over, which gives me negative x minus 5y plus 13 equals 0. And then I'm going to move the constant over. So I get negative x minus 5y equals negative 13. And I'm going to rewrite that under my top original. So now they're in the same format. I also like it because I notice that my x's are going to cancel. They cancel, which is nice. That's my objective. Can I get one variable? I'm going to combine my y's and I'm going to combine my constants. So the x's cancel. I'm left with negative 3y equals negative 6 divided by negative 3, and we get y equals 2. I'm going to plug it back in. I'm going to plug it back into this to find my x because it's solved for x, and that's more conducive. 13 minus 5 times 2. X equals 13 minus 10. X equals 3. And my solution should be 3, 2. And now I'm going to check the top equation. X plus 2y equals 7. Check. X plus 2y equals 7. 2y equals 7. X is 3 plus 2 times 2. 3 plus 4 equals 7. 7 equals 7. It's good. That is my solution. Again, they're not in the same form. I get x and a constant equaling a y. All right, I'll keep that in that format, that top one in the format. It's kind of weird, but it's okay. I want to show that it doesn't matter. For this one, I'm going to put the constant over there with the x, and I have negative 10x plus 5 equals 5y. So I just rewrote it. I guess I shouldn't do that. Let's do this. 5y equals negative 10x plus 5. Now, it's balanced, so I can rewrite it in that same format. That's okay. X's are going to cancel. My constants are going to equal negative 6 equals 2y divided by 2. Negative 3 equals y. Let's use this one. 5 times negative 3 equals negative 10x plus 5. Negative 15 equals negative 10x plus 5 minus 5. Negative 20 equals negative 10x. Divide by negative 10. 2 equals x. So my point is going to be 2, negative 3. And I have no idea which equation I haven't used yet. I don't think I used the top one. So 10x minus 11. Let's check. 10x minus 11 equals negative 3y. So 10 times 2 minus 11 equals negative 3 times negative 3. 20 minus 11 equals 9. 9 equals 9. And that worked. Okay. I'm going to keep the top equation again, just being consistent. And I got to make sure my bottom equation is in that same format where I have y and the constant on one side and my x on the other. So I'm going to add 6. I get 2x equals 2y plus 6. And we can rewrite that, just flip the side, because it's an equal, moving everything to the other side. So we get 2y plus 6 equals 2x. Nothing cancels. So we are at that point where, excuse me, so I got a bit of an issue here. So I now, after isolating and getting in the same, I now need to also manipulate. So I'm going to take this and take it without the, take it without that. So let's copy. Let's put this a little bit lower. So I'm going to take those two equations. Now, my y's don't cancel, my x's don't cancel. So it's not good for me to add. Technically, I could subtract the two, but that's way more complex. If I want my y's to cancel, I need them to be opposite of each other. So I'm going to take this bottom equation and I'm going to multiply all of it by -1. That gives me -2y minus 6 equals -2x. I distributed that -1 to all three of the parts. And I'm going to bring this equation over, 2y minus 4 equals 3x. Why is this better? Because now we see that my y's are opposite of each other. So they will cancel each other. They'll cancel out. I'm left with -10 equals x. Now, I'm going to choose one of the equations to find out what my y is. I'm going to just use the top equation. 2y minus 4 equals 3x. 2y minus 4 equals 3 times -10, substituting my x value in. 2y minus 4 equals -30. Add 4. 2y equals -26, divide by 2, y equals -13. So my solution is -10, -13. And I'm going to check which equation. I'm going to check the one I haven't used yet, which is 2y minus 4. 2y minus 4 equals 3x. Oh, no, I already checked that, sorry. I already used that. 2x minus 6. 2x minus 6, sorry. Check. 2x minus 6 equals 2y. Where 2 times -10 minus 6 equals 2 times -13. That's -20 minus 6 equals -26 equals -26. All right. That's good. Solve the system, check your solution. All right. Now, well, no, we're still, I wondered when they wanted us to. So we're going to put it in same format first. We may have to manipulate the equation in order to cancel. So if we subtract x from both sides, we get -x plus 3y equals 4. So -x plus 3y equals 4. That actually worked. My y's are going to cancel. I'm left with 7x equals -1. Divide by 7, x equals -1/7. Is that true? No. Mr. Mac made a mistake. Plus 3y, Mr. Mac. Plus 3y. So those do not cancel. We got a fraction. We knew that was going to be a little weird. So I'm going to take these two equations and I'm going to manipulate them. Copy. I'm going to paste. I'm going to group so you don't lose them. Thank you. I'm going to erase this. And then I'm going to do this. I'm going to move you guys over a little bit. Now, what variable do we want to cancel? I think it's best to cancel the y's because they're identical. So all I have to do is multiply one of the equations by -1. So this is going to give me 8x plus 3y equals -5. Didn't have to change that. I'm going to distribute the -1 in, which changes the sign of each of the terms. That's 9x equals -9. Divide by 9, x equals -1. I'm going to pick an equation. Let's pick the bottom one. -x plus 3y equals 4. Plug in the -1 for x. That's kind of tricky. Most students will make that mistake there. That's 1 plus 3y equals 4 minus 1 minus 1, 3y equals 3. Divide by 3, y equals 1. So I'm saying the solution is 1, -1. We checked the bottom equation, so let's check 8x. 8x plus 3y equals 5, I think it is. -5. Good that I checked. And let's plug in the points. 8 times -1 plus 3 times 1 equals -5. -8 plus 3, -5 equals -5. That worked. Solve the system. All right, they're in the same form. This is good. Let's get rid of this 7 for a second. Let's move that up a little bit so we can show the multiplication. This is number 7. So in this situation, they're in the same format. X, they're in standard form, but my x's don't cancel and my y's don't cancel. So we have to decide which variable do we want to cancel. If we choose the x's, I need, what would get rid of a 6x would be a -6x. So what do I multiply 3x in order to get -6x? Well, I'd have to multiply that top equation by a -2. I multiply it by a -2, I get -6x plus 8y equals -38. And then I'm just going to bring this equation, 6x plus 9y equals 21. So we see that the x's cancel. Now they are opposite of each other. That's going to give me 17y equals 17, -17, divide by 17, y equals -1. And now all I have to do is plug it into one of these equations. Let's do 6x plus 9y equals 21. 6x plus 9 times -1 equals 21. 6x minus 9 equals 21. Add 9. 6x equals 30. Divide by 6, x equals 5. 5 comma -1. Now we're going to check with the other equation. 3x minus 4y, 3x minus 4y equals 19. Plug in the x's and the y. Does it equal 19? 15 plus 4. 19 equals 19. It worked. Now, you ask, well, what if I wanted to cancel the y's? Good question. So let's do that. I know that's more work, but it's okay. We'll take the time to ensure that we understand all this. Let's erase all this work first. And we won't check it, we'll just know. So let's say instead of canceling out the x's, what if I wanted to cancel out the y's? So the y's have to be opposite of each other. So if I look at positive 9y, what can I multiply -4y to get positive, or to get -9y, right? Because what's going to get rid of a positive 9y is a -9y. Now, look, you can be challenging and difficult, and you can multiply by a fraction. You can multiply -4y by a fraction. 9/4 to get negative 9y, but to me that's just making it too challenging. Let's just look at these. They're opposite of each other already, so let's get a common multiple. So I'm going to multiply this by 9 and this by 4. That's going to be the easiest way. Now, our numbers are a little bit bigger. Yes, 9 times 3 is 27x. 9 times negative 4y is negative 36y. 9 times 19, 81. 171? 9 times 19. Yes, nice. And then we multiply everything by 4. We get 24x plus 36y equals 84. Now, my x's don't cancel. I have 51x. My y's cancel. And then I'm left with 14, 15, 255. Is that right? 255, 4? Yeah, that's good. I didn't need a negative. 4 is 5, so we're to 15. Yeah, divide by 51. 255 divided, it's going to be 5. X equals 5. And I plug it back into one of the equations. 6 times 5 plus 9y equals 21. 30 plus 9y equals 21 minus 30 minus 30. 9y equals negative 9. Divide by 9. Y equals negative 1. And was my point 5 comma negative 1? Yes, it was. So it shows that it doesn't matter which variable. You just want to do probably the one that does the least amount of manipulation. We only had to manipulate one equation here. When we solve for y, we had to do 2 equations. So for time purposes, you're going to choose the one that requires the least amount of work. Let's move this. Let's write this up here, number 8. So what do I want to get rid of? Well, this one I'm going to have to multiply both equations, no matter what. What's going to be the easiest? Well, I think if I multiply, I don't have to worry about negatives if I choose the x's, because those x values are opposite of each other. So I just have to find a multiple. So now I'm just multiplying by a number, less likely to make a computation error when I don't involve negatives. So 12x plus 15y equals 9. Don't forget to distribute to all 3, even the other side of the equation. We get negative 12x plus 8y equals 142. Let's combine. X's cancel. We get 23y equals 151. Divide by 23. Y equals 7. 151 divided by 23. Oh, I made a mistake. What do we do? What do we do? 4 times 38, 12. No. Oh, 2. 4 times 8 is 52. Oh no, 140. Oh, it's 152. Sorry, with 52, that's going to be 161. I still think it's 7. 161 divided by 23 equals 7. Yes, I knew the answer was 7. I just didn't do the math correctly. And let's pick an equation. 38, plug in 7 for y. Negative 3x plus 14 equals 38 minus 14. Negative 3x equals 24 divided by negative 3. X equals negative 8. So my solution should be negative 8, 7. Let's pick the other equation to check I'm staying consistent to my guns. 4x plus 5y equals 3, just to show you that checking doesn't take that much time and it is worth the effort. So that took 12 seconds, and I know that my answer, -8, 7, is correct. All right, number 9. I love it when we get to number 9. For those Beatles aficionados, number 9, a revolution. Number 9. Again, I'm going to tend to pick the variables that are already opposite of each other, that have opposite signs. So 3 and 2, and we get 24x plus 6y equals 66. We get 10x minus 6y equals 70. 34x equals 136 divided by 34. 8. No, it's not going to be 8. 4. 136 divided by 34 gives you 4. Yeah. Let's take an equation. An original equation is usually best. Times 4 minus 3y equals 35. 20 minus 3y equals 35. And you see how fast I go through this. The reason is because I'm so familiar with this, that I've done it so many times that I know where it's leading. 4, -5, check. And that's what I'm asking of you. Can you be so proficient? Can you be so well versed at this that you can blow through this not only fast, but accurate? Because fast doesn't matter if you're not accurate. So 32 minus 10, 22 equals 22. Okay, we keep going here. Couple more. Yep. And it's okay, right? Yeah, we're doing a lot of problems. Yeah, there's a lot, and they're similar. But it's the practice that I'm talking about. Going through and understanding the choices. Oh, what choices do I have? Which variable do I want to get rid of? Do I want to deal with negatives or not? I don't want to deal with negatives. I'm going to just continue. If my y values have opposite signs, then I'm going to eliminate the y's. The x's, because they both are positive, one of that manipulated numbers has to have a negative. And now I run the risk of not distributing correctly. Plus 21y equals 3. That's going to do 42x minus 21y equals 35, 105. That's 54x. These cancel. Equals 108 divided by 54. We don't need a calculator. That's going to be 2. 6x minus 3y equals 15. Doesn't matter. Yes, Mr. Mack, you keep choosing the bottom one. Well, it's just right there. It's more of a convenience than a reason. Minus 12, -3y equals 3 divided by -3, y equals -1. I have my solution to -1. Let's check. We're going to check with the top equation. 4x plus 7y equals 1. 4 times 2 plus 7 times -1 equals 1. 8 minus 7 equals 1. 1 equals 1. So I did that problem in less than a minute. Yeah, that's what you're looking for. That's what you're looking for. That's what you're trying to do. I think this was number 10. That was number 9, number 10. This is number 11. I'll write number 11 first before I erase. That. Okay. Yeah, this one's just going to be not fun. I'm going to multiply this by 8, this by 11. These are big numbers. Big numbers. 168x minus 88y equals negative 72. That is going to be negative 154x plus 88y equals 44. That wasn't too bad. No calculators. That's going to give me 14x. These cancel, equals negative 628, negative 28, divide by 14, x equals 2. Let's choose the top equation. Just because I've been choosing the bottom, it doesn't matter. My x value is 2, solving for y. 42 minus 11y equals negative 9 minus 42. Ooh, did I do a mistake? Did I do a mistake? I did. Forgot the negative in negative 28. So I was going to get a fraction here, so that should tell me that I made a mistake. So, and nice thing is, since I showed all my work, correcting that mistake is relatively simple. So all I had to do was add 42 instead of subtracting 42. And from 9 gives me 33. Divide by negative 11, we get y equals negative 3. So my solution is negative 2, negative 3. Let's check. And we're going to use the bottom equation this time. Equals 4. Negative 14 times negative 2 plus 8 times negative 3 equal 4. That's 28 minus 24. 4 equals 4. So just as simple, just as easy. Number 12. I think this is the last one before we get to our word problems. We'll see. Can't make any promises. Oh, well, 1 through 12, yes. So what are we going to get rid of? This is good. Let's do this one. Let's get the y's. And we'll see that we don't have to do 6 and 9. We can do, because they have a multiple of 18. So we would multiply this by 2 and 3. Getting rid of the y's, not the x's. I'm getting rid of the y's. So that is an LCM. So if we had chosen 9 and 6, we would have gotten a common multiple of 54, but it's not the least common multiple. So that'll keep your numbers down a little bit, picking those numbers. Negative 4x minus 18y equals negative 48. That gives me 5x. My y's cancel, equals negative 30. Divide by 5, x equals negative 6. Negative 2x minus 9y equals negative 24. Plugging in negative 6 for x. Negative 24, that's 12 minus 9y equals negative 24 minus 12. Negative 9y equals negative 36. Divide by 9, negative 9. Y equals 4. So my solution is negative 6, 4. Checking with the top equation, 3x plus 6y equals 6. 3 times negative 6 plus 6 times 4 equals 6. Where am I getting those numbers? I'm just plugging these numbers into that equation. Negative 18 plus 24 equals 6, and 6 equals 6. Boom! Describe and correct the error involving in solving for one of the variables in a linear equation. So I'm going to multiply the bottom equation by 2. Okay, that gets 4x minus 8y equals 18. That's okay. When we combine, oh no, that's good. That's where we made our mistake. We made our mistake right here. Oh, no we didn't. The linear equation system 4x plus 2x minus 4 equals 9. Describe and correct Describe and correct. So, oh, they're not opposite. These are not opposite. So I wouldn't have multiplied by 2. I would have multiplied by -2. Sorry, I was doing all the work. So I'm going to multiply this equation by -2, which gives me -4x plus 8y minus 18. Now my x's cancel, and that leaves me with, so we'll go over here. Now we'll go over here. So that leaves me with 13y equals -28. Divide by 13. Ooh, I made a mistake again already. -2, +8, -18, that's correct. That does give me 13y. That does give me -28. Are we going to get oh yeah, well, yeah, we do get a crazy answer. So divide, and we get y equals -28/13. Yuck. Describe and correct the error and some, okay. And now we're going to, so this is wrong. This should be this. It doesn't tell me to solve for y, or x, thank goodness. So we are actually done. We just needed to find what y equaled in that part of the equation, or in the process. In exercise 14 through 16, solve it using any method. Well, I'm going to use substitution. And that's where we get to, is we're going to use the one that is most conducive. What is it set up for? I'm going to substitute this in for x. So our choices are graphing, our choices are substitution, like in this example, or elimination through addition, subtraction, multiplication. So this gives us 1/3 y plus 5, which I plugged in for the x value, minus y equals 3. We're going to combine these two. You have a positive 1/3 and a -1, which gives us -2/3 y plus 5 equals 3. Folks, we should be very proficient at combining fractions. We're going to multiply by the reciprocal. These cancel. 2 negatives make a positive. We're left with y equals +3. Go back to this. X equals 1/3 y plus 5. Plugging in 3 for y. And we get x equals 1. These cancel, numerator, denominator. X equals 6. So my solution is 6, 3. 6, 3. Boom. Neither are set up, but I'm going to use elimination. Could I solve? Yeah, I mean, I could solve for x if I wanted and use substitution, but we're gonna stick with the plan. Let's make that -3. Oh, that's gonna make some ugly fractions, but it's okay. -3x. I'm not afraid to take a stand. Let somebody come take my hand. The x's cancel. -11y equals, this is halves, so 4 halves, which makes a -11 halves. -15 halves plus 4 halves gives us -11 halves. We're going to multiply by the reciprocal, which is -1/11. Denominator, numerator, negative, y equals 1/2. Plug it back into one of these. 3x minus 5y equals 2. 3x minus 5 times 1/2 equals 2. 3x minus 5 halves equals 2. -5 times 1/2 is super easy. Add 5 halves, add 5 halves. 2 and halves is 4 halves. That makes 9 halves equals 3x. We're not going to divide by 3. We're going to multiply by the reciprocal. Denominator, numerator, x equals 3 halves. Folks, get with the program and be proficient with fractions, multiplying, adding, subtracting, etc., etc. 3 halves, 1/2. Oh, did I write the number above it? No, that was number 15. And last but not least, number 16. Let's erase that so we can notate appropriately. Definitely we're not using substitution. Isolating doesn't really help us. We're probably just going to be easier to multiply by 5 and 2. I chose y because they have opposite signs. I don't have to worry about negatives. 8x minus 10y equals negative 6. Those are pretty easy. 70x plus 10y equals 45. 78x, the y's cancel, equals 39. 78, 1/2. 39 over 78, I'm pretty sure it equals 1/2. Just checking, yes. Yes, it does. I'm going to use the top equation. I had an opportunity to check with whichever equation I wanted. Why not make it easy? You don't get extra points from picking the harder of the two. So be smart. Divide by -5, and we get y equals 1. I don't have to check. I'm pretty sure it doesn't say find the solution and check. Explain your choice. So I explained. Yeah, I explained. Oh, I love this problem. These are really important. So you want some experience for high school placement tests. Solution problems are definitely. Solution A is 10% sodium water, and solution B is 22% sodium water. How many liters of each solution should you mix to make 30 liters of 15% sodium water? All right, so we know that A plus B must equal 30 liters, where A is the amount of liters. A is the number of liters of 10% solution, and B is the number of liters of 22%. So if that's the number of liters, it's going to equal the number of liters. Now, I'm going to multiply 10%. Now we can do 10, or we can do the decimal point. 10% of A plus, that's the diluted, and let's do 0.10. 0.22 of B should equal 0.15 of 30 liters. That's how we do it. It is the percentage times the amount plus the percentage times the amount should equal the total percentage times the amount. This is the part plus the part should equal the whole. And each part is a percentage times its liquid. All right, so now we have two equations. Don't know if you saw that we have two equations. We have equation 1 and equation 2. Now, if we want to simplify equation 2 and do that 0.15 times 30, you can, but we're just going to substitute. We're going to use the substitute method. We're going to change A plus B equals 30 into A equals 30 minus B, and we're going to substitute the A for the B part in the other equation. So where we see A, we're going to substitute this B portion so we can get rid of one of the variables. 0.1 times, instead of writing A, we're going to write 30 minus B plus 0.22B equals, and what's that, 45, 4.5? 4.5? 4.5? 30 times, no, it's got to be 45. No, it's 4.5 times 0.15, 4.5, yeah, good. Okay, now let's simplify through distributing the 0.1, so that's a tenth, so a tenth of 30 is 0.1b plus 0.22b equals 4.5. Let's simplify first. 0.12b equals 4.5 minus 3. Now we move 0.12b equals 1.5. Divide by 0.12, 0.12. We get 1.5. 1.5 divided by 0.12 gives us 12.5. B equals 12.5 liters of the B solution of 22% sodium water, 22% sodium water. So that's one of the solutions. Did you get what I said there? Solutions. Solution A and solution B. So that's solution B. Solution, and you get it, solution, meaning the answer. And now we know A plus B equals 30. A plus B equals 30. Plugging in what B equals, 12.5 minus 12.5 gives me A equals 17.5 liters of 10% sodium solution, so sodium water, which is going to be solution A. So we got 17.5 liters and 12.5. Let's go! Good luck with that one. Learn that one. That is an important skill right there. Solution, percentage of solution problems. It's relatively easy.